Channel networks HTLC. So now we're looking here into the syncing, how we can sync different payment channels, and specifically we'll be looking at HTLCs. So a payment channel network is nice because it connects two entities, but what if these two entities don't have like a connection to each other, like a direct connection? So in that case, we need to go through intermediaries, right? So we have to kind of hop here across these intermediaries, and that's what the syncing is referring to. We need to sync a payment channel. So if you want to send a payment in this direction, we have to send first the payment here, then the payment here, and then the payment here. And they should all execute atomically or fail atomically collectively if one of them fails. So we need a simple conditional transfer. So let's first discuss the idea of a humble conditional transfer. So let's say we have a random number r, we take the hash of it, and this hash h is something that Jackson is basically sending over here. So Jackson computes this hash h of r, and he shares this with Michaela. Michaela then says, well, Jackson, if you reveal r before time t, you will get the coin. Right, so let's say here you have Michaela has one coin that she wants to give to Jackson. If you reveal r before a given time t, then you get this coin. And Jackson will then reveal r, right, because he wants to get this coin. And because Michaela cooperates, she will give this one coin, right? She's cooperative, everything is good. Basically cooperative in the sense that she agrees he sent this r before time t. Now, what if Michaela doesn't cooperate and is malicious, right? What happens then? Well, that's where we go to explore the hashed time-locked contract, or HTLC, as we can find them in literature. So it's basically just a conditional transfer attached with some evidence. Now, let's say here you have a blockchain and you have some time t, and let's say Jackson is submitting his proof, his evidence of HRT and the coin that she wants to have to the blockchain here in this particular block. Then the blockchain can confirm that Jackson revealed R before time t and that he complied with the contract that he had with Michaela. Right? So he receives the coin. The chain can basically give him the coin. I mean, a blockchain in a sense is nothing else like as a timestamp ledger, right? You can kind of record time, or at least the sequence of events on this ledger. So it's a perfect use case of a blockchain. Now, how do you apply this to payment channel networks? Well, you can apply the same to actually perform these payments here, right? You can use HTLCs in order to define at what point in time a particular transfer should be made. And this allows us to synchronize a payment among peers on the path. There are also other approaches of doing so. You can, for example, use a path-based virtual payment channel. So we can set up virtual channels to avoid intermediate peers to be responsive. Then you don't have to communicate on the network latency. You basically just go directly from the source peer to the target peer.